Section 1.4, Displaying Quantitative Data, Stemplots. Now, you've probably seen Stemplots before, although it's a little less likely that you've ever had to actually make one by hand. So our data set here are the electoral votes awarded in a presidential election for all 50 states and the District of Columbia. If we wanted to make a stem plot of this data, the first thing we're going to do is make the stems. Now, when we talk about a stem plot, we'll have a stem, which is the first part of a number, and then the leaf, which attaches to it, which may be confusing if you haven't seen a stem plot before, but it should make sense in a minute. So when we look at these, there's a lot of minimum values. The minimum value is 3. That's the first one, but you'll see a bunch throughout the table. Oops, that's not a 3. The maximum value is this one right here, California, being the one that has the most electoral votes. And just for reference, New Jersey has 14. The larger the state, or I should say the larger the population in the state, the more electoral votes awarded for that state. So we want to pick stems that'll fit our minimum and maximum. When we look at these single digit numbers like this 3, we're really reading it as 0, 3. Okay, when we look at the California value, 55, and the stem is the first digit in each of those. Okay, so our first stem is a 0 all the way up to our last stem, which is 5. And from there, we're going to add the leaves. So as we take a look at this table, we're going to look at them one at a time. When it's a one-digit number, like this first one here, it's a 0, 9. We're going to put the 9 on that 0 stem there. Then we go to the next one. The 3 is a 0, 3. We'll put that there. Okay, the 11 has a stem of 1, because remember, it's the first digit that makes the stem. Since it's 11, we'd put the 1 there. So a stem and a leaf attach to give us that 11. Here's a 9 followed by a 3, etc., etc. All right, so when we look at this 55, it would be down here. When we look at this 29, it would be here through, and write all the stems, all the leaves for each value attached to those stems. Now, the tricky thing is that we want these in ascending order. So once we have them all listed out, like we see here, we want to rearrange them and put them in order. Okay, and then the last thing we're going to do is write a key on the data. So here you can see we took all these values, okay, and we just rearranged them to put them smallest to biggest for each of the stems. And then we always have something like this, because we're not always working with integer values. Like let's say we were making a stem plot of gas prices, where say this is our stem was a 4, and then over here we have a 2. That might represent $4.20. So we want to note in our key, like, how are we actually reading these values? Another variation of a stem plot is a split stem plot, and this is when we have data that has a lot of leaves in a single cell, or maybe a few cells. So in our current stem plot here, we see this stem of 0 has a whole bunch of data in it. And we might want to split that up to get a better representation of the data. So when we do a split stem, we're going to split that 0 through 9 into 2 parts. So it's going to go 0 to 4 in our first stem, and then 5 to 9 in the next one. And then we go into the next stem, that 1, and we would do the same thing. So it would be 10 to 14, and then 15 to 19 in the next one. So there's a high group and a low group. Each one counting the numbers from 0 to 4 in the first one, and then 5 to 9. So if we were to recreate our stem plot as a split stem plot, it would look like this here. Now let's use this split stem plot to answer some questions. So if we're asked what percent of states get 10 or more electoral votes, so the 10s are starting right here in this stem. All those zeros are the 10s, and obviously we want everything bigger than that as well. So we're just going to add all the values from that stem and below. Okay, when we add them all up, we get 21, and that's out of 51 total values, because it's the 50 states plus Washington, D.C., and we get 41.2%. Describe the distribution of electoral votes. Here we want to use SOX, shape, outlier, center, spread. And one of the nice things about a stem plot is that if we take it and we flip it on its side, you can see the distribution, the shape of the distribution. All right, so what I mean by that is this one is going to be skewed to the right. Okay, remember the ones on the bottom of the table here? are the larger values. All right, the tail is on the right, which means this is skewed to the right. So we would go ahead and go through SOX there. The distribution of the electoral votes. Remember, we always want this in context, so we want it to be writing about what this graph is displaying. Is skewed to the right with a center around 8. California and Texas, 55 and 38, are both high outliers, and the range is 52. Okay, again, right now we're just ballparking those. We're picking a center value. Spread, we're just using range, but later on in this chapter, we're going to go over a few ways to calculate those mathematically. Another variation of Stemplots is called a back-to-back Stemplot, and we use this a lot when we're trying to compare distributions. So in our data set here, we have information on oak trees, specific species of oak trees on the Atlantic coast and the California coast. And this is telling us the average diameter of their acorns. So if we wanted to compare these distributions using a Stemplot, again, like I just said, we're going to use a back-to-back Stemplot, and we're going to have a single stem that's large enough to accommodate both data sets. So we're going to look at both of these data sets combined and find the minimum and maximum across both. So the minimum looks like it's this 0.3 right here. So the minimum is in the Atlantic data set, and then the maximum is this 17.1 in the California data set. So we have our stem here going from that minimum to maximum, and we're going to put each data set on one side of this distribution. So all the Atlantic values are going to go on the left, and all the California ones are going to go on the right. Okay, we're going to have our numbers in ascending order again, but they're going to move out from the center. So the ones in the Atlantic data set, when we put them on the graph on the left there, the smallest numbers are going to be closest to the stem, and they're going to increase as they move out away from that stem. All right, and always don't forget the key. Okay, this is what it would look like when it's all filled in. You can see it kind of looks like it's going largest to smallest. All right, but really we're reading it this way. Okay. All right, when we look at this, we can see the differences. You can see this huge outlier down here in California. You can see their shapes are a bit different. And it gives us an opportunity to answer questions like these. Which of the two regions typically has larger acorns? All right, we want to look at the whole data set. When we look at Atlantic coast, we can see there's a bunch of data up here in a smaller range. California's way more spread out. Okay, so we're going to say California has the largest set of acorns. It would have a higher center. Okay, the middle for California is going to be about here. I'm using the median, where the middle for Atlantic is somewhere in that batch. All right, which region has more variation? Again, this is California. It's a lot more spread out in California, where in Atlantic coast we have a lot of values in that first two stems there. Okay, remember always write your answers in context and reference specific values. Okay, so I'm talking about that 0 to 21 centimeters, where we're seeing most of the data in Atlantic coast.